Okay, dear friends, I start with lecture 17 of Math 304. Now, as I said in the previous lecture, in the last moment of previous lecture, that we should continue this sum, and I hope you have done this. It is up to you. If you have done some calculation, then check that whether it is matching with this calculation or not. That we have to see. So in the previous lecture we have calculated all these penalties, and the 17 is the maximum one, and therefore among that 0 is the minimum value, and therefore we can do maximum possible flow at this entry, and therefore it is 1820, and therefore this is done. Okay. Now we calculate the other entries, and therefore we have to calculate other 4. See here, whenever there are two numbers are equal, at that time we say that the penalty is equal, means the difference of equal numbers, and therefore it is 0. Here it is 8. This is unchanged, so we have tie at that 8, 8, 8. If we use this 8, then we can use 5. If we use this 8, then we can use 9. If we use this 8, then we can use 9. At this 8, we can do 76 of flow. At this 8, we can do 76 of flow. But at this 8, we can do 72. Means either we have to use this or this. I think it is advisable to use this. Means I can do 76. Therefore, this is done. Now we calculate again the penalties, and therefore it is 8, 8, 8, 0, 8. So if we use this 8, we can do here how much flow we can pass. We can pass 72. Yes, we can. Therefore, this is done. Now again we calculate 8, 8, 8 and 8. So now this sum is of minimum cost entry method. Means here we can do 41. So this is done. 61 means I can do here 21. 97 means only 5. See here, 7, 5, 22, 8, 10. Okay, done. So what is the cost of transportation that we have to see, and for that we calculate. So friends, 76 into 9, that is 684. This is 0. 21 into 25, 525. 72 into 9, 648. 17 into 5, that is 85. And say 41 into 17, that is 697, and therefore this sum is 2639. And this is by northwest corner rule. This is by minimum cost entry method, and that is by Owen's method or least cost entry method, least cost penalty method. So that is the much better than other two. So in exam you have to directly do this sum by this method and go further by other method. Go for the theta method. We call it Modi method. Now we eliminate all these things. Okay, I do it here. So we have basic variables are this one, then this one, then this one, done, and one more. So dot, the number of dots should be n plus n minus 1, so it is 3 plus 4 minus 1, so that should be 6 dots. 1, 2, 3, 4, 5, 6. Okay, we have 6 dots. Now we put 0 here, means it is 9, 25, 70. Means we are going to calculate ui and vj, and therefore it is minus 8. Minus 8, minus 25. So now we calculate Cij minus ui plus vj. So it is positive, 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 it is 0. It is positive. It is positive. So this is the optimal solution. There is no solution other than this solution. It satisfies all supply and demand. So we continue in the same way, but in the next sum I will take a special type of transportation problem, because first I write the statement of that sum and then I will explain what is difference. So dear students, this is assignment problem, which is special type of transportation problem. Now here we have A, E, C, D and E. These are origins where our car is parked. 5 cars are parked at these places, and A, B, C, D and E. These are 5 destinations where we require car. I am giving you this example, and this is the distance between this origin to this place. Distance is in obviously in kilometer. So which car should be sent to which place, though the distance should be minimum, and each place means each person required one car. There is a flow of one car. Means this is a special type of transportation problem, because supply and demand both are same. Supply of one car, demand of one car. 5 origins, 5 destinations. So this is for example. Let me check this statement again. 160, 135, 140, 50, 55, 130, 120, 110, 50, 175, 130, 155, 80, 70, 190, 160, 170, 80, 80, 200, 175, 185, 110, 1. Okay, I repeat the same again. This is assignment problem. Assignment problem is a special type of transportation problem. How it is special? Because there is a 5 origin and 5 destination. 5 cars at these 5 places and 5 cars are required at these 5 places. So we should send which car to which place such that this distance should be minimum. And satisfaction of all these things. Means it's a transportation problem, you know. Clear. Try to understand this problem and think that how to solve it. So first what we are doing, in the first row we choose the minimum value, means it is 130. Subtract it from each end. Find the minimum value of first row and subtract it from each element, each entry of the first row. I find 130 is minimum and therefore we subtract 130 from each of these, means it is 30, 0, 45, 60, 70. Then 120 is minimum, 50, 0, 10, 40, 55. Then 110 is minimum, means it is 30, 0, 45, 60, 75. Then 50 is minimum, 0, 0, 30, 30, 60. Then 35 is minimum, it is 20, 0, 35, 45 and 70. Now I would like to check it once. 30, 15, 30, 0, 20, all 0, 45, 10, 45, 30, 35, 60, 40, 60, 30, 45, 70, 55, 75, 60, 70. Okay. Then what we do in the next step, we find the minimum entry in the column and subtract it from each of them. So from column 0 is minimum, means it is 30, 50, 30, 0 and 20. All entries are 0. Then 10 is minimum, 35, 0, 35, 20 and 25. Then 30 is minimum, 30, 10, 30, 0, 50. Then 55 is minimum, yes. Here it is 50, 15, 0, 20, Here it is 5 and here it is 50. By subtracting each row and each column by minimum number, we have 0 in each entry. Each row and each column we have at least 1 0. Think that. Okay? Because we subtract the minimum entry from each row and each column. Let me check once. 30, 15, 30, 0, 20. All 0. 35, 0, 35, 20, 20. 30, 10, 30, 0, 50. 15, 0, 25, 2. So here, now what we are going to do? We are going to do cover all zeros. How it is? See here. Okay. Cover all zeros by dotted line. This dotted line says that there is 0 and we have to cover it. Now here very carefully. We should draw all lines in such a way that minimum numbers of lines should be plotted and all zeros should be covered. And one thing more, there should be minimum number of intersection at 0. See here, we draw in the second column, we draw the straight line, dotted line, and in the second row and in the fourth row, all zeros are covered. In the next step of this, we choose the minimum number from uncovered line, and that is 15. I repeat this statement which I said just before this statement. Cover all zeros by dotted line, and zeros should not be in intersection as much as possible. But we lost 2 zeros. How we lost it? Because then we find the minimum number from the uncovered, means it is 15. We have to subtract each number cover all zeros by dotted line. Clear? Second, try to draw minimum numbers of lines. Find try to draw lines in such a way that intersection should not be at 0. This intersection at 0. Try to do that. But if you want to draw these lines very in that way, your intersection at 0 is unavoidable to do that, then you have to cover all zeros by dotted line, try to draw minimum number of lines, and try to draw lines in such a way that intersection should not be at 0. Should be. Should not be. If it is not possible, then try to do that. But as soon as possible, try to do less intersection at 0. As this is first sum. But all these things are very easy for students, because I have noticed in the previous years, once I give this idea in your mind, whether it is LPG problem, two-phase method, big method, integer programming, transportation problem, assignment problem, any type of problem of operation research, students are doing much faster calculation than me. And I have noticed. Now 15 is minimum. Now I stop this calculation here, and I would like to continue the same thing in the next lecture. Thank you very much.